Hello, this is Mr. Brooks and welcome to Lesson 10.5, Trigonometry and Area. In this lesson, this time we're going to do Part 1, Finding the Area of Regular Polygons using Trigonometry. Alright, in this lesson we're going to use a formula for area of a regular polygon, which is 1/2 the apothem times the perimeter. Area is the big A, the little a is the apothem, and P is the perimeter. The apothem is the distance from the center of a regular polygon to the side of the regular polygon, and you must go perpendicular to the side. Let me show you what I'm talking about. So here we have a regular pentagon with each side 8 centimeters. As you can see, the apothem is CY, distance from the center perpendicular to any side of the regular polygon. So we're going to do 1/2 the apothem times the perimeter. Well, obviously the perimeter is going to be 40. The distance around the outside of the figure would be 5 times 8, 40. But we have to figure out the apothem. And to figure out the apothem, we're going to use a trig function. But before we can use a trig function, we got to figure out the measure of the angle. I just put 2 arcs on. Measure of that central angle. Measure of angle XCY or YCX. Well, hopefully you could figure out the measure of all the blue arced angles. It's simply going to be 360 divided by 5. So all the blue arced angles are going to be 72. So this angle with the red arcs on it is going to be 36. Now we're going to use a trig function. We also know xy is going to be 4, because it's going to be half of 8. Xz is 8, so xy is 4. So which trig function? We got the measure of the red arced angle, which is 36. We know the opposite side, and we're trying to find the adjacent side. So hopefully you remember your trig functions. In this case, tangent, which is opposite over adjacent. So the tangent of 36 degrees is going to equal opposite, which is 4, over little a, the apothem. So we multiply both sides by little a. Our little a's cancel on the right, so we get a times the tangent of 36. Then we're going to divide both sides by the tangent of 36. Alright, so we get the apothem to equal 4 over the tangent of 36. So the area of this figure is going to be 1/2 the apothem, 4 over the tangent of 36, times the perimeter, which we already said was 40. Then you're going to plug that into your calculator and hopefully get the area of the figure to be approximately 110 square centimeters. Okay, in quick check number 1, they want us to find the area of a regular octagon with perimeter 80 to the nearest 10. So please pause the video while you try to figure this out. Well, I tried to draw a regular octagon. Just pretend that all those sides and all those angles are the same. Then I drew what's called the radii from the center to each vertex. And then I drew the red arcs, are the angles formed by all the radii. Well, to get that, you do 360 divided by 8. So hopefully you would agree that each of those red angles is 45 degrees. Which again is area equals 1/2 the apothem times the perimeter. They already gave us the perimeter of 80. So all we got to do is figure out the length of that blue segment. Well, to get the length of that blue segment, the apothem, we're going to have to get the measure of the blue arced angle. Alright, we know that if there's 8 sides and the perimeter is 80, that every one of these sides is 10. So this little side right here is 5. So again, we're going to use tangent, which is opposite over adjacent. So the tangent of that blue arced angle, hopefully you agree, is 22.5, half of 45 degrees. tangent of 22.5 equals opposite, which is 5, over the adjacent side, which is what we're trying to find, the apothem. So the apothem is going to equal 5 over the tangent of 22.5. You can multiply both sides by a, then divide both sides by 22.5, but hopefully you can do that in just one step, where you exchange the a and the tangent of 22.5. So now the area is going to be 1/2 the apothem, which is 5 over the tangent of 22.5, times the perimeter, which is 80. So you're going to plug into your calculator 200 divided by the tangent of 22.5. Running out of room there, but that's 22.5. So plug that into your calculator, see what you get. 200 divided by the tangent of 22.5 gives you the approximate area of the regular octagon to be to the nearest tenth would be approximately 482.8. Hopefully that's what you got. Example number 2 asks us to find the area of the regular octagon in the Castel del Monte, which is a castle built in southern Italy circa 1240. If you look up circa, it'll say it was built about, circa means about, the year 1240. So we're talking about 800 years ago approximately. So how are we going to get the area of the regular octagon, which is in the middle of this castle? Well, here's a better picture of the regular octagon, which is in the inner courtyard of the castle. It tells us that the radius of the regular octagon is 16. Now again, a radius is the distance from the center to each vertex. Each of those are 16. Each of those blue lines are 16. All right, and each of these central angles right here are going to be 360 divided by 8, which is 45. Well, again, just like in the last one, if those are 45, then the measure of the given angle that they have is going to be 22.5. All right. This time, not only do we have to figure out the apothem to get the area of this inner courtyard, we also got to figure out x, and then we're going to multiply x by 16 in order to get the perimeter. All right, x times 2 would be the length of each side, and there's 8 sides. Well, first, let's figure out the apothem. Hopefully, you remember that cosine equals adjacent over hypotenuse. So cosine of 22.5 is going to equal the adjacent side, which is little a, over the hypotenuse, which is 16. So the apothem is going to equal 16 times the cosine of 22.5. Alright, that's the apothem. Now to get x, we're going to use sine. Sine is opposite over hypotenuse. So the sine of 22.5 is going to equal x over 16. So x is going to equal 16 times the sine of 22.5. Now, like I said earlier, you're going to have to multiply x by 16 to get the perimeter. So the apothem equals the area equals 1/2 the apothem times the perimeter. So you're going to do 1/2 the apothem, we got to be 16 times the cosine of 22.5, and the perimeter is going to be 16 times x, and x is 16 times the sine of 22.5. If you press all this into your calculator, you're going to get the approximate area of the inner courtyard, which is approximately 724 square meters. Okay, the last one we're going to look at is quick check number 2. It says the radius of the main structure, again the main structure is a regular octagon, is twice the radius of the inner courtyard. The radius of the inner courtyard was 16. So how does a regular octagon with radius 32, how is that area going to compare to the area of the inner courtyard, which was 724? Please pause the video while you try to figure this out. Here's my regular octagon with the radius of 32. All of these central angles are going to be 45. So this red arced angle is again going to be 22.5. This is a regular octagon. Alright, we got to figure out the apothem, and we're going to have to figure out x. Well, again, to get the apothem, we're going to have to use cosine. Cosine of 22.5 is going to equal adjacent over the hypotenuse, 32. So the apothem is 32 times the cosine 22.5. To get x, we're going to have to figure out, or we're going to have to use sine. Sine of 22.5 equals opposite over the hypotenuse, 32. So x is going to equal 32 times the sine of 22.5. Now remember, we've got to multiply x by 16 to get the perimeter. So the area is going to equal 1/2 the apothem, which is 32 times the cosine of 22.5, times the perimeter, which is 16 times x, which is 32 times the sine of 22.5. Please plug this into your calculator and see what you get. Hopefully you got approximately 2,896. Now, quick check number 3 says, how does this area compare to the area of the courtyard? Well, it is 4 times greater. So when you double the radius, you get an area that is 4 times greater. This concludes Lesson 10.5, Part 1.